Hello again. Now I will present to you the process discovery algorithms or plugins in Prom. I will start by the alpha minor algorithm, since this algorithm is the first plugin or process discovery plugin that was implemented by vendor Ast. Okay, and now we have to put alpha like this. Here we can have the information boxes. We can have information here about the algorithm, and we start. Here we have a set of version like alpha plus, alpha plus plus, alpha robust, and because alpha, for example, the original alpha wasn't not robust, and he can treat, for example, loops and non-local dependency between activities, etc. Now I will just run alpha to show you how it works. Excuse me. Here we have the Petri net. We have a Petri net. Here we have a set of places, set of transition arcs between transition, and we have here the name here of the transition. But as you see here, we don't have a sound Petri net. This is we have deadlocks and we have not sound Petri net. Okay, now we will move. I will show you how the inductive miner can be used in Prom. So the inductive miner is again one of the algorithms that is able to take the event log data and produce a process model. Okay. We don't need this Petri net. On this XOS log, we can run the inductive miner. Inductive. Okay. This is the plugin. I have to remember that the inductive miner algorithm applies a divide and conquer approach by splitting event logs into smaller parts and recursively find models to offer these sublogs, which are later combined. Okay. Okay, now we will run the plugin. Start. Here we have also a set of version, and here there is the original inductive miner. Here, for example, the infrequent, what we use frequently, it's the plugin of the inductive miner version that treats the noise, and he can filter the infrequent behaviors from event log. Okay, I will choose infrequent, and now I have my Petri net. Okay, so like alpha, we have set of places, set of transition. Black boxes here comes from the conversion between process tree and the Petri net. Okay, what I can say, I think the strength of the inductive miner consists of its ability to detect the starting and the ending point, and okay, and the intermediate steps also, and the arcs presented in the model makes easier the understanding of different paths followed by user to accomplish their task. Okay. Inductive visual miner now, however, there is also the inductive visual miner. So let's go to see the inductive visual miner. We don't need this from the XOS file. We mean inductive. There is the inductive visual miner. Okay, and we will select this plugin. Now we have visualization, This plugin discovers a process model at first, and when it has found a process model, it automatically aligns the data with the process models. And when it has finished it will when it has finished it will show you an animation. So this is an interactive visualization. Okay, here for example we can reduce the number of activity, as you see here, and here for example we can reduce the number of paths, but here we can't because the data is very small. Here we can have an idea on the process tree, and here we have can have an idea or the deviation on the deviation. Now we can see what is the deviation of our process model. And we have other option, which is the directly follows miner. Okay, this is the first step of the inductive miner algorithm. He constructs a directly follows miner, and this plugin was proposed recently in the ICPM conference by Sander Leemans also. Okay, now we will move to the fuzzy miner algorithm. However, he is a different process discovery algorithm, since it does not discover Petri nets but process graphs. Okay, let's move to fuzzy miner algorithm. From our XOS, fuzzy mine a fuzzy model. Now, he discovered a fuzzy model from the given log. Please note that fuzzy model is really an entire family of fuzzy instances, and that the visualizer of fuzzy model typically shows only a single fuzzy instance. Okay, here we have a set of metrics used in the algorithm of the fuzzy miner. We can put it like that, but you are free. You can just select one of them. Okay, and here we can put it like that, and now we will discover our fuzzy miner. Here we can understand that the, for example, catalog show is the most important activity, has one, and here also it's an important activity, and this arc, it's more important than this deviation or this arc. Here we have an edge filter. Okay, here we can have all the arcs between activities. Okay, and here for example we can have the conformance or the conformance between the log and the model, and here we have the detail of all visible nodes in the model, in Discover model. Other option that we can export the fuzzy model, and after that we can make visualization between the fuzzy model, the exported fuzzy model, and the XOS event log, and we start the animation. Now we can zoom. We can see all the interactions, and here we align the log on our process or our fuzzy model. Thank you.